So 15.8 is next, substitution in multiple integrals and change of variable. So first recall single variable, what you do. If you have this form, so if, f of x is a function of another function, basically you can do a substitution, right? That's when you let u be something, then you do du, and you get the g prime in here. So you've been doing some of that. This is the basic form for single variable. This is the form we use, although it's not really how you would see it, but you pick u to be something inside the function, and then you take its derivative, and you get the extra derivative on the outside because of the chain rule. And then you have to write it in this form before you integrate with respect to u. Okay, so it's kind of that idea of what to do with multiple integrals. So a double, we're going to focus just on double integrals. You can extend this to higher orders, but we'll stick to just two variables functions like this. So to take a look at a double integral for region R of f of x dA, and then so x and y you write as functions of two other variables, u and v, right? So where x is equal to g of uv and y is equal to h of uv. Then this form here, these are partials, basically, and this is what's referred to as the Jacobian, which I don't think I wrote that down in the paper there, but so what you do, these are absolute values, so it's the absolute value of this calculation. So that calculation is actually a determinant, which looks like this. So it's the determinant of, and then you do absolute values. So it could be a little slightly confusing, I guess. So this notation means partial x respect to u, partial x respect to v, that's the top. Partial y respect to u, partial y respect to v, that's the bottom. And then you do this determinant. Okay, so you get that. So in general, change of variable, I'll just read this to you, is given by a one-to-one function called a transformation from the region G in the UV plane to the region R in the XY plane. So T of UV is equal to X of Y, or this form. Okay, and these are continuous and have continuous first partials, basically. So first, let's do the calculation of that. So suppose you have u is, so you're going to basically choose u and v and then solve. You'll have to show you how we do this. So in your functions, you'll be choosing u and v, and then writing x and y in terms of u and v. So what you can do here is look at your equations, like u equal to x plus 2y, and then v equal to x minus 2y. And then if you add those, you will eliminate y, and you'll have x in terms of uv. And then you do the same technique to get y in terms of uv. So if you just add these, and you get u plus v is equal to 2x, or we would write x is equal to 1/2 u plus v. And then similarly, u equal to x plus 2y, and v equal to x minus 2y. Then, and if you just subtract those two, then you will end up eliminating x. So you'll have u minus v equal to 4y. So y is equal to 1/4 u minus v. So we want to do that. That's what we'll be doing in our actual question. We want to do that so that we can do the partials. So remember the partials up here is partial x, u, y, v. So that's, you need it with respect to x and, or with respect to u and v in this form. All right, so now let's calculate the Jacobian. Okay, so calculate the Jacobian. And so you'll write partial xy with respect to uv. So it's partial x respect to u, partial x respect to v, partial y respect to u, partial y respect to v. Then you do this determinant. So it's probably best to just go ahead and now do those calculations of each one. So partial xu, here's my x and u, so you'll have 1/2. xv will also be 1/2. yu will be 1/4, and yv will be -1/4. So you get 1/2, 1/2, 1/4, and -1/4. Okay, and then that's equal to -1/8 minus 1/8, so it's -1/4. And then in your formula, you'll actually, back up here, take the absolute value of that. And so this just becomes positive. Okay, so let's look at an example. So evaluate the double integral over r of e to the y minus x over y plus x dA. Then we got to tell you what r is. Where r is the trapezoid with vertices 0, 1, 0, 2, 2, 0, and 1, 0, and we'll be sketching that. So we'll sketch that a little bit. We'll go through this kind of step by step. It doesn't have to be exactly this order, but I'll try to do it sort of algorithmically. So we'll do number 1 is we can choose our u and v. So you can choose u and your v. It doesn't really matter the order, but let's go ahead and choose u because choose the obvious choice is y minus x. And v will be y plus x. So let u equal y minus x and v y plus x. Now write x and y in terms of uv, like we did above. This will be very similar to what we just did above. So you have u equal to y minus x and v equal to y plus x. So there we can add again, and you'll eliminate x, and so you'll have u plus v equal to 2y or y is equal to 1/2 u plus v. And then subtract, we'll just keep it there, right? You can subtract those. And you'll have u minus v equal to negative 2x. So you'll have x equal to negative 1/2 u minus v. And you can rearrange or distribute that as desired. It doesn't really matter right now because you're going to just do the partials anyway. So step 3, let's calculate the Jacobian. So calculate the Jacobian. So partial xy respect to uv. Okay, so I suggest write it out. Partial x respect to u, partial x respect to v, partial y respect to u, partial y respect to v. So you write it out. So you don't have to memorize it, of course, just know it better. And then you can do those partials and substitute into the determinant. So go ahead and try those, xu, xv, yu, yv. Okay, and you'll get negative 1/2, 1/2, 1/2, and 1/2. Okay. So then do that calculation. It's negative 1/4 minus 1/4 is equal to negative 1/2. And then the next really important aspect is the regions. So regions in the x, y, and uv plane. So you want to sketch the regions in the xy and uv plane. So first, let's do r in the xy, because that's kind of what was given. It was originally in xy. Okay, so I'm going to draw on my coordinate system. It's in 2D, of course. All right, so then you get the vertices are given here. So you have those. So we're going to draw those vertices down here. And we know it's said it was a trapezoid, so you know how what the rest of the region looks like. So you have 1, 0, 2, 0, 0, 1, and 0, 2. So let's go ahead and zoom in a little bit on this. So 1, 0, 2, 0, 0, 1, and 0, 2. Okay, and then let's connect this for our trapezoid. So it's going to be like this and like this. And then you have these sides as well. So that's our trapezoid. And so you want to figure out the line, the equation of these lines. So you have the vertical axis and that's horizontal, then vertical axis, but you want to find out the equation of the line. So it's easy to calculate that. It's x plus y equals 2. And then this one is x plus y equal to 1. Okay, so figure that out. Okay, so then, a little too far there. Let's calculate, or now draw the region in the UV plane. So how is that mapped basically to that other region? So what does that do? So that's what we want to figure out. Okay, so draw on your coordinate system again. Actually, because I know what this looks like, we're going to do this differently. All right, so the your choice of UV, you can find out where particular points go. So what you have then is you have U equal to y minus x, v equal to y plus x, and then you have xy transformed to your uv. So do this chart basically, and you can put in all of those points. So this point, right, all of those points, and figure out the transformation. And you can kind of manipulate and mess with the equations to figure them out, but they should become pretty clear. Okay, so let's go ahead and do the points. So 0, 2. This is just what I have. Doesn't really matter the order you do this, of course. So you get, so do this calculation on your own. Okay, so you have those points when you do the transformation. So labeling those points 2, 2, 1, 1, right? So there's 1, 1, 2, 2, and then negative 1, 1. And then negative 2. And so this one is this region. So you kind of can guess, but I'm going to go and put it in. May wanted to do a couple more steps to figure this out, but this is what, okay, that didn't work. Okay, so 2, 2. And this one is your negative 2, 2. So note that you have x plus y equal to 2. Well, that's 2, so v is equal to 2. So v equal to 2 is this line. Right, so this line here is your v equal to 2. So this is your uv is usually how we write it. And then this line will be v equals 1. This will be v equals u. And this will be v equals negative u, or you could write that as u equals negative v. Either way will work. So those are your regions in question. So I'll just do it in this color, I guess. So here's your region in the UV plane, and here's your region in the XY plane. So now you want to integrate over that region. So normally you may want to go, you go vertical, but if you go vertical, then you have 1, 2, 3 different regions to integrate over. And you can't necessarily use symmetry because we don't know if this is symmetric, that's like above or below that region. So you got to be careful of that with symmetry. So we may not want to use that. We want to go this direction. So a representative rectangle needs to go this way when you integrate that region. So this is the direction we're going to go. We're going to go from u equals negative v to u equals v, or we may end up choosing it to be negative u, but you've got to go from this side to this side, left to right. Okay, so let's set this up. This is a double integral over r e to the y minus x over y plus x dA, and that's going to be the double integral over g of e to the u over v, there's our substitution, and then absolute value of negative a half is our integrating factor that we calculated, dA. And so that, oh, well, let's do our g. So that's the double integral. And we're going to go from, so now we're going to switch the order and go left to right. So we're going to say u equals negative v to v. And then 1 to 2, factor out the half, e to the u over v, du dv. And from there, you can do that calculation. So go ahead and finish that, and then I'll have it written up here, and then we'll go on to another question. We have I have a couple more to do, which these do take a while. Nothing real complicated about these, but they take quite a while to work through them. Okay, so we'll do 2 more examples on this.